So today we're going to talk about determining different material types. We're going to a little bit of detail here, but if you have any more specific questions, go ahead and throw them in the chat and we will follow up with you during this call. If there's anything we can't get to, again, feel free to email us at training@geophysical.com. So, as I mentioned, we'll be uncovering how to identify material types, more specifically, metal versus air versus water. We'll also talk a bit about how to really take advantage of the oscilloscope and how that's going to help you in terms of not only identifying material types, but getting an even more accurate depth reading with your horizontal cursor. We'll look at more specifically as it relates to material types, the different color patterns that you will see representing different amplitude values, which can give us a little bit of information on the type of material that the radar is traveling through. So let's start with the way that the system initially understands the data as a series of these scans all stacked together. Okay. Now, if we were to take one of those individual scans and draw a line right down the center of it, we would say that anything to the right is going to be positive, anything to the left is negative. Now, instead of looking at a bunch of wiggly lines on the screen, we assign color and pixels to help us to better interpret what we're looking at. So we say that anything with a positive amplitude value is labeled as white, and anything with a negative will be labeled as black. This is how we get an image like we see below here, where we have those shaded hyperbolic shapes on our screen. So more importantly, let's look at what the different material types are going to be viewed as on our screen based on what we just talked about. So we have three main material types here that you'll encounter. We have metal versus air versus water. Now the PVC, or whatever the encasement is for that particular linear target, is more or less irrelevant in this case because we're more concerned about what's inside of it. And that's what the radar is actually displaying to us. So in other words, if we see an air-filled PVC, the radar is going to react to that air, giving us a specific color pattern, which will help us then identify that material type based on what we're seeing in the data. So let's say we have some concrete with a dielectric of 10. Now, if we encounter metal, metal has an infinite dielectric, right? So GPR, for all intents and purposes, cannot pass through metal because it's a perfect reflector for GPR energy. It's going to bounce right off of it like a mirror, okay? So if we're going from a low dielectric to an extremely high one, we're going from a low to a high number, which is a positive change. In this case, the first strongest color is going to be white. So what we see in our data is this black, white, black pattern, okay? Now, if we look at where our horizontal cursor lines up towards our oscilloscope, we have another way of viewing the data here, okay? So as long as we're in ScanMax and we have display set to A plus B, we have the ability to take advantage of this oscilloscope, okay? So what that's doing for us in this case is it's just giving us a different way of viewing the data. So in terms of depth accuracy, as we're lining up our cursor horizontally and then viewing what our depth reading is at the top of the screen, we can either more or less eyeball it to figure out where the dead center of that white is. But in addition to that, we can also pop over here to our oscilloscope and see that everything checks out. It's towards the right side, which lines up with the white color, and that cursor follows right through our oscilloscope. Now let's say we have a air-filled PVC. So where the radar energy now is going from a higher number to a lower number, we are viewing that as a negative change, okay? So if you hadn't guessed, In this case, the first strongest color is going to be black. So in other words, the pattern of colors displayed with a air-filled PVC in this case is going to be this white, black, white pattern. Now, if this is unclear, we can always check ourselves and look at our oscilloscope. Obviously, this thing is wiggling back and forth in a series of positive and negatives, but where we line up our cursor as it relates to the hyperbola in our data, we're seeing that it goes all the way to the left in this case, as opposed to with metal where it goes to the right. So in this case, we can identify these targets as air-filled. Most of the time, you're going to be seeing metallic uh, patterns, right? So you're going to see this black, white, black pattern. In the event that you see something like this, it's probably going to stand out because the whole color pattern is going to be inverted. Again, if you're not sure, just reference your oscilloscope and you have some additional information there to make the best assessment. Okay, lastly, we have a water-filled PVC. So now, much like metal, we're going from a low number to a high number. Okay, so this would be a positive change. Again, like metal, our first strongest color is going to be white. But here's the thing. If you look at this compared to the metal targets, it's not going to be as bright. Okay, and the reason for this is because the change isn't as strong, right? So the larger the dielectric change, the stronger the reflection, and the brighter that image is going to be produced at. Okay, so the brighter that target will appear. If it's a smaller change with a weaker reflection, the target will be much dimmer. So in the case of water, if you have a water-filled PVC, your oscilloscope is still going to be displaying positive, but if you look closely at the data, the water is reflected as a target, not quite as bright as metal. So metal is always going to ring like a bell. It's always going to bounce right off of it. So it will produce a nice bright white display. Now, lastly, I wanted to cover just a couple things here. We get asked a lot. I see someone had already asked in the chat, so that's great. The difference between metal and conduit, or rebar and conduit, rather. So a couple things to note here. So we have a couple different data sets, right? We have rebar, and then we have what we refer to as wire mesh, okay? So with rebar, we typically have fairly uniform spacing, okay? We can view this in more or less a straight pattern. Now with mesh, any of you have done some construction, you know the process for pouring concrete with wire mesh allows or causes the mesh to sort of create this undulating pattern, which is a pretty good identifier when you're trying to tell the difference. So now we're trying to figure out where our hazards are, right? So anything that's not reinforcement, anything that could be a hazardous situation if we were to cut it. So we have PVC, post tension, conduit, things of that nature. Anything we want to try to avoid at all costs. All right. So in this case, where we have PVC, we already know that the color pattern is going to be different. But let's say that this target here has a similar color pattern as the rebar. In this case, we want to focus more on the context, right? So the context in this case is telling us that, you know, it's likely this row of 5 hyperbolas here is likely rebar because it's got that uniform spacing. But then we have this rogue element kind of coming in out of nowhere that doesn't match a particular pattern. This is what we want to mark as a hazard, right? Because this could be something potentially dangerous.